proportional and non-proportional situations. How can you tell the difference between a proportional and a non-proportional situation? We're going to take a look at it several different ways, and hopefully by the time we're done, you should be able to tell the difference. So let's first take a look at a graph. One of these is proportional, one of these is not proportional. If we look at the graph, we'll notice that this graph passes through the point 0, 0. This one here passes through the point 0, 6. We know that in order for it to be proportional, it must go through the origin. It is not proportional when it passes through another point other than the origin. So that's our first part of our definition of proportional versus not proportional. Our second part of our definition deals with equations. Here we have two equations, y equals 2x and y equals 3x plus 15. Now one of these is proportional and the other is not. The difference, as we can see it, is over here on the right, it has a y-intercept of 15. On the left, there's nothing sitting out there, which means it's 0, and this has a y-intercept of 0. When we have a y-intercept of 0, we know that that's proportional, that there's nothing else going to affect the change, that the change then becomes constant. Here, whenever we get a number other than 0, we know that it is non-proportional. So let's review right now. So far we know if it's proportional, the line of the graph will go through the origin and the y-intercept is 0. If it's not proportional, the line of the graph will pass through any point but the origin and the y-intercept does not equal 0. So let's add one more thought to this, and I'm going to use these words: constant of proportionality. Okay, and we're going to use y divided by x. So this constant of proportionality is going to help explain why something may be proportional or not. So let's take this apart. First, the word constant. Constant means the same thing all the time. Proportionality, if you remember, if we had a proportion, we basically have two fractions that are equal to each other. So here I have two tables. One is proportional and one is not proportional. And the best way is to evaluate the constant of proportionality. So we're going to take a look at the y and the x values as an ordered pair. This first one, if I take 4 and divide it by 1, that equals 4. If I take the second pair and do 8 divided by 2, that also equals 4. And the same is true for 3/12. If I take 12 and divide it by 3, it equals 4. Since I get the same number all the time, it is constant, we can say the constant of proportionality exists for this table of values, so therefore it's proportional. Now there's a reason why this one is not proportional. Obviously one is one and one is the other, but let me show you so that you can see, in fact, the numbers, why it's not proportional. Again, we're going to use this x and y values of the ordered pairs. Here I'm going to have 5 and divide by 2, I get 2.5. Here I have the pair 3 and 7, so I'm going to take the y, which is 7, and divide it by 3, and I get 2 1/3. We can already see that it's not the same. But let's just do one more to make sure we all understand. 9 divided by 4 is 2 1/4. So we can see the constant is not the same. The constant of proportionality does not exist. Since it does not exist, it is not proportional. So we need to know all three aspects of something is proportional or not proportional. So the title of our notes, though, is dealing with situations. So let's take a look at a situation. We're going bowling and we have the following information. We have from Bowl-O-Rama this equation, y equals 3.5x plus 2. And the lucky 5 lanes is given it to us in a chart format. So we'll deal with Bowl-O-Rama first, and we know that the y is always going to represent our total cost of money. So when we think about bowling, we usually play a cost per game. So this 3.5 is going to represent that cost per game. That means this fixed number, this additional 2, this fixed fee, because it's fixed, it's not changing, it's not being multiplied by anything. In terms of bowling, it's probably the shoe rental. So at Bowl-O-Rama, we're going to pay $2 to rent shoes, and then what we're going to do from there is pay 3.5 per game. So let's see if we can do an analyzation of the lucky 5 lanes. Now, because it's in a table, the best thing for us to do is check the constant of proportionality. So 4.25 divided by 1, is that the same as 8.50 divided by 2? It is, and since these are exactly the same, that means there's no fixed fee. They're only charging us $4.25 per game. And that means that there's no rental fee or no shoe fee for us here at the Lucky 5 Lanes. So if we would just wanted to explain what was going on, we could say at the Bowl-O-Rama, it's going to cost us $3.50 per game plus a $2 shoe rental. At the Lucky 5 Lanes, we're only going to pay $4.25 a game, and there'll be no shoe fee. Now, the best way, though, to really compare things is to make a table. So I'm going to draw a table here, and we're going to give this the table of the Bowl-O-Rama. And we're going to put some information in this table. Okay, so what we'll do is we don't need this upper corner here. So this is 1 game, 2 games, 3 games, and 4 games. And we also have the cost of shoes along with the cost per game. And if we add those together, we're going to get our total cost. So let's start out with shoes. Well, if I play 1 game, the shoes are $2. And it doesn't matter if I pay 2 games, 3 games, 4 games. I'm paying that $2 shoe rental cost no matter what. So that's going to be in addition to the games. Now, if I look at my games, we know from our equation that our first game is $3.50. If I have 2 games, 2 times $3.50 gives me $7. 3 times $3.50 gives me $10.50. And 4 times $3.50 will give me $14. Now I need to figure out the total cost, which means I'm going to add these two together, the shoes and the game. So here I have a total cost of $5.50. Here I have a total cost of $9. Here I have a cost of $12.50. And here I have a cost of $16. So now to do a comparison, we need to sit and evaluate where is it going to be good at what point. So here, if we're only going to bowl 1 game, our best bet at 1 game is to bowl at the Lucky 5. Because it's only $4.25, where at Bowl-O-Rama it's $5.50. The same is true if I only want to bowl 2 games. Again, we're going to go to the Lucky 5 Lanes because 2 games are only $8.50. Where things start to get better for us to go to the Bowl-O-Rama is when we get to 3 games and 4 games or more. Because then the Bowl-O-Rama is cheaper. So if we were going to do an analysis, we would say that if you wanted to bowl 2 or less games, go bowl at the Lucky 5 Lanes. You want to bowl 3 or more games, you're going to bowl at the Bowl-O-Rama. So hopefully this technique of knowing when something is proportionate or not proportionate can help you realize where fixed fees are, be able to do a comparison and an analysis.